Hello, today we're looking at internal and external angles of polygons. Now, internal angles are fairly straightforward, i.e. they're the angles inside the shape. Now, external angles are slightly different in the fact it's not the whole of the angle, it is the angle from the shape extending out a line along the edge of the shape to there. So for this hexagon, there is the external angle. If we take this square, again, we need to think about going along one edge, line it up, and there is the external angle. Okay, etc, etc, etc. So you're extending the edge, and it's the angle between that extended edge and the next edge is the external angle. But the question is, how do we calculate the external angle? Now, the sum or the total of all the exterior angles always has a connection. Okay, so if we take this protractor, you'll clearly see what's happening. Okay, so the protractor starts like that. Okay, now as I move around the shape, matching side to side, you will see that eventually when it gets back up to the top, we're back to 360. Again, if we do it with the hexagon, you can see that as I go around the shape, the protractor twists, and by the time it gets back up to the top, it has twisted round a full turn of 360. So we know the sum of the exterior angles is 360 degrees. So if we know, say for example, we have a square which has 4 sides, we can take that 360 and we can divide it by 4 because the square has 4 sides. Therefore, we can work out the external angle is 90 degrees. So just to recap, we're going to take our 360, divide it by the number of sides. So here, again, how many sides does a hexagon have? 1, 2, 3, 4, 5, 6. So I can take 360 divided by 4, not divided by 4, Mrs. Patmore, divided by 6, gives us 60 degrees. Have a go now with the triangle. Find the number of sides and divide that into 360. Pause the video while you do that. Well, obviously a triangle has 3 sides. So we've got 360 degrees divided by 3 will give us 120 degrees. But where is that 120 degrees? Again, we take a side, we extend it out, and it is the angle between the edge that is extended and the next edge. So this is how we find the external angles. The internal angles are far simpler to find. We know that a straight line has 180 degrees. Therefore, if we know the external angle, we can use that to find the internal angle. So for the triangle, oh, hold on, the internal angle of the regular polygon, okay, because all the sides are equal, all the angles are equal on each individual polygon. All the sides are equal, all the angles are equal on each individual polygon. So going back to this, the internal angle is your 180 subtract your external angle. So in this case it's 120. That means the internal angle is 60 degrees. With the square, we know it's going to be 90. We know what a square is, but we can still use the maths. 180 minus the external angle of 90 gives us 90 degrees. Have a go now with the hexagon. We know that the external angle is 60 degrees. Work out what the internal angle is of the regular hexagon. So we have 180 minus the external angle of 60 degrees gives us 120 degrees. Now the three examples that I've picked, I've been able to do easily mentally. If, however, the calculations are getting too difficult, sometimes these can be calculator questions. So use your calculator, in particular on the higher numbered sides.